Hello everyone, welcome to my channel. In this problem, I am going to discuss problem which came in educational code forces round 152. So problem name is binary string copying. In this problem, we have given with a string s which consists of n character which are 0 and 1, and we have to make m copies of this string. And if let's suppose ith copy is string ti, then we can perform exactly one operation on each copy. What we can perform, we can sort its substring l comma r, and we have to count that number of different substring that it will form. Let's I take first example, then I will explain the problem. So in first example, we have given this string 00, and operations we are given with 1 2 1 3 2 4. You can write here 1 2 1 3 2 4 5 5 and 1 comma 6. Let's take first operation. In this, we have to sort substring 1 comma 2. Means we will sort these substrings. After sorting this, it will become 0 1 1 1 double 0. In second, we have to sort 1 comma 3. Means this 3 we have to sort here to here. So after sorting this, it will become 0 1 1 1 double 0. In next operation, we have to sort 2 comma 4. So means we have to sort from here to here. So after sorting, it will become 0 1 double 1 0 0. Next operation, we have to sort 5 comma 5. So means we have to sort this element. So it will become 1 0 double 1 0 0. And in next operation, we have to sort complete string 1 comma 6. So it will become triple 0 1 1 1. So as you can see, this whole string is same. So it will be counted as 1, it will be counted as 2, and it will be counted as 3. So that's why answer to the first case is 3. So now we are coming how to solve this problem. Let's take these substrings only and analyze. So we have 1 0 double 1 0 0. So let's suppose we have given an substring l comma r to sort. So what happen when we actually sort this l comma r? When we have to sort l comma r, first place where we are getting 1 and last place where we are getting 0, that too will be impacted. Because let's suppose I take this example 101. So in this first place where 0 occur is this, and uh, the first place where 1 occur is this. So basically these two will be impacted and this will be not impacted. I explain this with more example. Again we take string. Let's suppose we have to sort this. So last position where 0 is occurring is this, and first position where 1 is occurring is this. So basically from string here to here will be impacted and this will remain unimpacted because 0 is already here sorted. So after sorting, this will be remain same 1 0, and this will be impacted and it will be changed to 0 0 1 1. So I can say for every l comma r, the substring which is given in the question, there will be exist two unique positions from where to where that strings will be impacted, and we have to count that only, and that will give us the answer. So basically a solution to the problem is this only, and just we have to implement the solutions. So let's move to coding part. Yeah, I already written the code, but yes, for convenience and better expression, I again write the code. So it is this, and I will again start writing the code again. I think till here we can leave, and from here I again explain everything. So we have taken n and m. N is the length of the string and m is the number of query, and we have string s. and I have converted this string to digit from 0 1 character form because it will be easy to implement. Now what we have to do, we have to find first L comma R where to where it will be impacted, and for finding that we will use prefix sum techniques, and we can use binary search on it because that is one of the standard method to find this kind of thing. So I create a vector of prefix sums of size, I take n plus 1, and prefix sum of 0 I can equal to str of 0. I will build my prefix sum array. Now we will iterate on our options what we have is substring L comma R. So for that, first we take that substring as input, and we will here we have to take such m queries, so we will do m minus minus, and we will take input L comma R, and we will push it into the our vector. Now we start iterating on our queries, and before starting that, like we will store unique positions, like so we have to store unique L comma R from where to where it is impacted. So for that we create a set, because set will always store a unit variable, and we declare it, and here we find our leftmost point of the query, and we find the rightmost point of our query. Now we find first position from left where 1 occurs. So to find that, I take an example and then I can show you. Let's suppose we have substring 1 1 0 1 1, and let's suppose again we take 0. So when we will find prefix sum, its prefix sum will look like 0 1 2 2 3 3 3 4 actually. So let's suppose we have complete this substring. So in this substring, first one is occurring here. So for that, what we will find, we will find the value which is present at leftmost point, and we have to find the first position. Let's suppose the value at leftmost point is, if it is L, so we will find first position where the value become L plus 1. That will be the give position where the first one occur. And one case is there, like if this is only 1, so in that case we handle separately. So for that we can write, and before that, one more thing we have to do, we convert it into 0 based indexing. So if string of left is already 1, so we like no need to find our position of 1 because we already got. So we can create two answer variable, name it as first one and first 0. So if left is equal to 1, we already found our first one. So in first one we can store left, and if we not found left, now we used to find our element using binary search we can find. So we can declare an auto index, and we have to find lower bound because we will find first position, and we have to use binary search on prefix sum array. So we can write prefix sum dot begin from left up to right we have to find. So prefix sum not, sorry, prefix sum not end, it will be prefix sum dot begin plus right plus 1, and we have to find the value which is occurring on first left position plus 1. So like here it is 0, so we'll find 0 plus 1. So here we can give what value is occurring at left position plus 1. So this will give us that our index of 1, and we have to verify because situation can occur like we have substring like 0 0 0 0, so that index will go outside, so we don't need to do that. or let's suppose we have one is here but our substring is from here to here only, then also it will go outside our substrings. So we have to handle that cases. So we can write like this: if index minus prefix sum dot begin is greater than equal to or less than equal to, it should be right, then we got our correct index. So we will store it in first one. Okay, now first part over. Now second part is again we need to find last position from right where 0 occur. So again we check like if at rightmost position only we have 0, so no need to find, we got already 0. But if it is not, then we have to find. Now for finding this we have to use again binary search. So like I take an example, like we have 1 0 1 1 1. So yes, we can take this, and so this 0 is will be our position where it occur. Its prefix sum will look like 1 1 2 3 and 4. So we can observe that till here to here prefix sum is continuously decreasing, and till here it decreases, and but after this it remain constant. So where it is remaining constant, that will be the only our answer. So it will be not like much easier to implement by using lower bound or upper bound of inbuilt function what we have. So we have to implement our own binary search in that. So we take L equal to left and R equal to right, basically the range of substring what is given. And now we will start binary search on this. This is basically a standard binary search. So if you are solving a C-level problem of Codeforces, you can easily write this. So again, first we find what is available. Available will be basically prefix of right minus prefix of mid, and here in calculating mid we have to use L plus R. Yeah. So basically like if we, let's suppose this is only our mid, so available or not, let's check this, let's take this. If we are standing on this, then available we are calculating prefix sum of right minus prefix sum of mid, that will give us 4 minus 2. And if it is equal to right minus left, means right minus left will be also equal to 2. You can see like if we index this 0 1 2 3 4, so right minus left will be equal to also 2. So if these two is equal, means all the elements right to this is filled with ones, so we have to search on left side. So we have to do this only. So if we find available is double equal to right minus left, so means all elements are available on left side, so we do right equal to mid minus 1. And if it is not the case, our element is on the right side, and we will go for that, because we need to find the maximum index from we have to find the first index from right side, so we'll go to that side. And we have to check the condition every time. If our mid is double equal to 0, means we found that, so in answer variable we can store or answer equal to maximum of answer comma mid we can do. And here we can declare an answer variable. So after this completing whole while loop, we will get our answer, and we can store it in our variable of first 0. First 0 will be equal to answer. Yeah, so after executing these two, we found our first 0 and first 1 position. Now we have to go through some cases, like if first 1 double equal to minus 1 or first 0 double equal to minus 1. This means that our entire substring is filled of only one character, because let's suppose we have entire substring of 1 1 1, so we not got the 0. So in this case, string will always remain sorted. So just we can push st dot, or what set I have declared. Yeah, st I have declared. So st dot insert, sorry, st dot insert, I can do -1 comma -1, because it denoted our string is already sorted, so we don't need to do any operation. And one more case we have to consider here. Let's suppose if string is like this, 00011. So first 0 will come here, and first 1 will be come here. So 0 is like left of 1. This denotes that string is already sorted, so we don't need to consider again this case. Again we'll put -1 comma -1, means string will remain same. So we take that case also into the account. Yeah, uh, otherwise we will put our first 0 and first 1 position. And at the end, how many unique characters are there, it will be given by size of set. Yeah, now we can run and try this. St dot size, which is non-class type. What is happening? Let me check. Okay, here declaration we done wrong of pair. Something, I think, mistake we have done. So let's check it once. This is correct, and yeah, binary search, I think some mistake is there. No, no mistake in binary search. Okay, here it will be right minus mid. Let's debug our code, then only we can able to figure out where we have done the mistake. So I am printing left and right. Okay, it is not coming here, so something mistake we have done here. Test case we have taken, NNM we have taken, string we have taken, while prefix we should, it will not affect, but okay, here it is going infinite. Here is the mistake. Now let's run the code. 0102, again it is stucking somewhere, so we have to find the wrong position. On 02 it is not able to run properly, so first we check either mistake on first condition or in second condition. So I print it here and check. Okay, it is printing, so mistake I think is here only in this one. This mostly I can say in our binary search mistake is there. Okay, yes, so it will be R and this will be L. I think it should run. Let's see. Let's comment it out and check. 211. So again some mistake I have done. First 0, first 1. Okay, it will be first one greater than first zero. Okay, now it is running fine. Let's submit the code. Okay, yes, it's accepted. Yeah, so thank you very much for watching this video.